one of each type. Let's just see if you recognize what rule to do and how to set it up. This is the time to get a better understanding so we can perform on your assessment. And let's kind of work on our perseverance. Like Friday, some of you just kind of, once it gets difficult, you want to quit. We need to work on that. Okay. So on the first three, all of these are just combined like terms. So I'm just going to put CLT for 1, 2, and 3 for this first row. For it to be a like term, it has to have same letter and same exponent. So if I look, this has I wish my pen was showing, but it's not. It has a to the third and b squared. So that's the same and that's the same. So when you're combining like terms, you keep the variable and the exponent the same. And you just focus on the coefficient. Well, that's 3 and 5. So I'm saying 3 minus 5. What is 3 minus 5? So that's what goes in front of the letter and the exponent. So I know you can probably do some of these mentally. Make sure you're picking the right like term. Now I can get the ruler. There it goes. On 3, you have to kind of set it up. 2, the only like terms are the xy and the xy. Those are the only ones you can combine. You leave the x squared y in your expression. So we're subtracting a negative 2y from a negative 6y. So negative 6w, sorry, negative 6w minus negative 2w. So the w is the variable, it stays. Now we just focus on the coefficient. A negative 6 minus a negative 2. Negative what? Yes, negative 4. If you're struggling on the computation, use your calculator just to check. Yes. Yes. Negative 6 minus negative 2. Negative 4. Okay, so now you have to apply the rules. It's a mixture. It's all operations. So on 4, the key is this multiplication. So we just add the exponents when you're multiplying. But if you have parentheses, like on number 5, and you have an exponent outside the parentheses, this is when you multiply. So this would be negative 8x 5 times 2, which is just a negative x to the 10th power. Division or a fraction is showing the quotient rule. This is when you subtract the exponents. I know some of you can do that mentally, but you need to write the variable with the exponent in simplest form. This is when we get into a combination. I'm going to jump to number 8 because you have the power rule, the parentheses with an exponent on the outside, and you have multiplication. You need to do one at a time. That should have been blue for me. I would do the power rule first. I'm putting this exponent to each item inside the parentheses. So this would be rewritten as negative 2 to the second power, x now to the fourth power, y to the second power. That is going to get multiplied to the next monomial, which is a negative 3xy cubed. Now, we need to simplify this negative 2 to the second power. What is a negative 2 to the second power become? Huh? Yeah, this right here is really just 4. I'm changing that to a 4. So, do you see what numbers you're multiplying together? And then what exponents you're adding together? If you don't see an exponent, it's an invisible 1 above the letter. So, did anyone simplify number 8? Negative 12, x, 5, yep, to the 5th power, y to the 5th power. That is right. Okay, so 10 is like number 8. It's just that all we have to do is distribute the exponent to each term. So the first thing is negative 4 squared, and this y now becomes to what power? 8. All you need to do now is simplify that number. Like I said, I'm going to get you started. I want to see if you can finish it. 11 has 2 power rules. We have a parentheses here with an exponent of 4, which I'm distributing to each one. So what does this become? The first binomial. A to the 8th power, B to the 4th power, C to the 12th power. Yes. We're going to multiply that once we simplify this next power rule. If I have b squared c raised to the power 3, it's going to now be b to the 6th power, c to the 3rd power. And now we're just adding the exponents. There's no a to add, so that stays a to the 8th. But there's a b and there's a b. Then the c's. Okay. So b to the 10th power and c to the 15th power. And there's our final answer. Now we're getting into negative exponents. But you still do the power rule first. So we're still going to distribute the exponent of a negative 3 to each term. So this is 6 to the negative 3 power, c to the negative 3 power, and a negative times a negative now makes that positive, d to the 3rd power. So whenever we have negative exponents, we need to think of this term over 1 and flip it to make it positive. So when I rewrite this, this is 1 over 6 to the 3rd power and 1 over c to the 3rd power. My d to the 3rd power stays as is because it's positive. What's on the bottom goes to the bottom, stays at the bottom. Whatever is positive goes to the top. So the d to the 3rd power is on the top of the fraction. My 6 to the 3rd power, we have to get that number. What is 6 to the 3rd power? 200. So we have 216 c to the 3rd power. So the key to this is you need to simplify each rule one at a time, and then apply the next rule. Yes.
Which goes on top of that?
Positive powers goes on top. So this was a positive 3, so it went on top of the fraction. These are on the bottom already, so they stay on the bottom. Yeah. So on 13, if I distribute this -3, this was saying 4 to a -3, a to a -3 times a to a -4. And what I could do, because these are being multiplied together, the same a's, here we're adding these exponents. So I would have 4 to the -3, a to the -7 power. And can I keep it like that? So now what do we have to do? We need to flip it and put it to a positive exponent. So notice that both of these are coming to the bottom. So we're going to have 1 on the top, 4 to the 3rd power, a to the 7th power. What you need to do is figure out what 4 to the 3rd power is using your calculator. Yes. So you need to do one at a time. Like on 14, you need to do this one first. And then, or actually no, this one first. Sorry. They're both power rules. So I would do, raise that to that power first. And then I would do to this power, to each term, second. And then multiply them together. Now, if you have a fraction, which is like showing the quotient rule, you still subtract the exponents. But now you just have to simplify the numbers. If I don't see an exponent, you have to know that's like an invisible one there. So on 16, I would just simplify the 9/3. Do you have that answer? Is that why? Oh. This gets simplified to just 3, and we're subtracting the exponents. When you do 8 minus 10, that is d to the -2, and you cannot keep that negative exponent. So you have to flip it. So when I flip it over 1, 3 is on the top, d to the 2nd on the bottom. (17), you need to reduce this fraction. That can be reduced to 3/2. Then I'm just subtracting my exponents. A to the 4th power, which is positive, but now I have b to the -1, which I cannot keep. So you have to simplify this one. The last row is a combination of power rule and quotient rule. Exponents always come first before multiplying and dividing. So on 19, you need to distribute the 4 first, get the new number on top, put it on the number on the bottom, and then simplify. On 20, you have to distribute to the top and bottom. So 3 to the 4th power, x to the 20th power, y to the 12th power is on top. The bottom is x to the 12th power, y to the 24th power. Because you did 4 times 6. And now we're subtracting and simplifying. So on 21, we need to distribute first, then simplify it, then subtract, get that answer and subtract it by the 8a to the 3rd b. Okay, so you're going to finish the ones I didn't do. The back will be used for scratch work on the Desmos. The Desmos will tell you specifically to work out the problem. And it will check you as you work it. Okay? This is a grade. If it's done, if the front is done, I'll come by and stamp it in class. I will be doing a stamp check of 1 through 21 first.